You've all heard of it. It's like a buzzword now. What is AI? Well, all AI is any computer program that tries to imitate a higher human function. So in video games, we can see this as bots or chatbots. Now, in a general sense, these are like pre-programmed. So once they get a response, there's a pre-programmed response that they give. Now this is really boring. I don't like this. Let's move on. So within this general definition of AI, we have this subset called machine learning. Now, what this does is it takes data and it will learn from the data. This is more interesting because we can basically teach a computer to do something. And it'll predict something based off what you give it, and then it'll improve its predictions. Now, this is usually used in statistics, as it's kind of hard to set up. It's a little, you need more knowledge to use it. So, within this subset, there's another subset called deep learning. Now, this is all the cool stuff that you've heard of. ChatGPT, DALL-E 2, which is image generation, and Alexa use deep learning. Now, what this is it's a machine learning program that mirrors biological neurons. So what it's doing is just recreating a brain. Now, how does this work? Well, we have our neurons, like a human brain, and we feed through, forward through a neuron layer. So we start with a neuron, and we pass our value of that neuron, and we pass it through a function to each neuron in the next layer. Now, each of these connections is unique. So that's what gives it a randomness in a way. Now, let's say we have a model, and we want to recognize a cow, as we see a cow here. Now, how we do this is we take our cow image, we take the RGB values, and we just give that to our model in our input layer. And we see our values here, and we flow forward through the model using each individual connection to update the next layer until we reach the last layer of our model. Now, this is where our model decides what it thinks what we give it is. Now, in this case, it thinks it's a dog. Now, this doesn't really look like a dog. I mean, at least to me. So, why does it think it's a dog? Well, we haven't trained it yet, so it doesn't actually know what it's looking at. So, to train it, what we do is we give it cows and dogs. And basically, we just make it predict, is this a cow or is this a dog? And if it guesses wrong, we then say, you've guessed wrong, go back through, and we basically use really complicated math I don't understand to find what is the best change we can make. So we basically go back through, we change the weights and biases, which was the function, and then now we see it works. It sees a cow, it says a cow. How can we use this? Well, first, I'm going to talk about chatbots. These are really one of the most popular implementations. Then image generation, it's pretty cool. And then drug discovery, because that's my personal favorite. It has the most effect, and has the potential to change a lot of lives. So, if we're going to talk about chatbots, why not talk about the king of chatbots, ChatGPT. We've probably all talked to it, right? So, how does it work, or what is it? Well, ChatGPT is a generative, pre-trained, large language model. Now, it's a lot of words, but all this means is that it's pre-trained, so we don't have to train it on our own inputs. It's large, and it specializes in language. So, yeah, it's the deep learning. But how big is it? The one you've talked to is ChatGPT 3. Now, this is the smaller version. It's 800 gigabytes. For comparison, on my phone, I have the Shrek movie. That is 40 megabytes. So ChatGPT is 20,000 Shrek movies. The bigger version, ChatGPT 4, is 1 trillion parameters. This is the rumor. So what does the parameter mean? Well, parameter is a stored weight or bias. So, with the 1 trillion parameters, we get about 88.75 billion neural connections. The human, the average human, has 1 trillion. So, it's about as tenth as smart as you are. Yeah. So, what does this mean? Well, ChatGPT 4, so this is the newer version, it got a 90th percentile on the bar exam, so it's a lawyer, 99th percentile on the bio-Olympiad, so it's a biologist, and it got a 1410 SAT, so it could get to college. So, how does this work? Well, we have our model here, right? This is trained already. We take our input, and we take any previous conversation we had with it. So what allows it to understand context. And what it'll do, it'll predict the most likely next word. So, if we do this, and we repetitively do this, it will just say the same word over and over again. And that's not really a conversation. So what we do is we take the word it predicted and put it back into our conversation or our context. This allows it to generate paragraphs of conversation. And when it reaches an end, a sequence, it'll just stop. So, that's how it works. Now, we know how chatbot works now. What about image generation? These are pretty cool. So, how do we do image generation? Well, there's multiple methods, including GANs, which we're not going to talk about because they're kind of bad. We have stable diffusion, which is like the most common. And then we have the newer latent diffusion, which really complicated. I don't understand how it works. So, most platforms use stable diffusion. This is Denali, Stability AI, and Midjourney. If you heard of those, that's pretty good. And then here's some images we have, if you can see them. We have Doctor Strange, a dragon. It's a pretty cool dragon. We have a bunny on vacation. And then we have the Pope dunking. Yeah. Apparently he's good at dunking. So, how does this work? We can generate some pretty good images, right? So we have our cat. And now what we're going to do is we're going to mess up the image of the cat. We're going to mess up the image of the cat. So you can kind of see the cat still, but it's also really messed up. So now what we do is we take our model and we say, take this and get it to that. And we do it in the same steps as we add noise or distort the image. Now, this is image to image. How do we add text to this? Well, what if we tell our model, this is a cat? Well, our model will know if we go from here to here and we see the cat, then we generate that image. What if we say, cat wearing a hat? Well, it says, when I do this with the hat, I get a hat. And when I do this with the cat, I get that. So why don't I just add the cat and the hat together, and we get that image. So, we know how image generation works. I'm going to talk about my personal favorite, drug discovery. So, drug discovery, sorry, we're not talking drugs, but it can be used in all aspects of the drug discovery process. So, we're talking drug analysis. This is toxicology and effectiveness. We're talking determining protein structure. This was big a while ago with AlphaFold. And we can suggest drugs for testing. Now, this is where you get advanced like drug discovery and stuff like that. We can optimize synthesis, and there's a new thing, a prediction protein function. This has not been possible before, and there's a $50,000 reward if you build the best model. The best accuracy for the model that I've seen is 1%. So good luck with that if you're going to try that. And according to McKinsey and Company, which is a consulting firm, AI has the potential to reduce the time it takes to find a new drug by 90%. So, how do we do this? So, how a drug works is that we have a drug and it binds to a receptor. Now, like this. And this is called the binding affinity. We can measure the binding affinity, and that's the effectiveness of our drug. So how can we do this? We can do this in a cell. This is like what we've been doing for like 100 years. But this takes a lot of time and a lot of money because we have to synthesize the drug and we have to get our target. Now, it's not really effective. It works. But we can also do this in a computer. How we do this is that we simulate every single atom in that environment, and we simulate every single interaction. This is really inefficient. I think I heard that 200 microsecond simulation took like 3 days to predict. So it's really not that efficient. What we can do, though, is take our simulation and train an AI model on that. So our AI model will infer physics. Now, once we get to enough effectiveness, we can just put our drug and a receptor into our model, and we get our binding affinity. No longer 3 days, like maybe an hour or 2 hours. What we can also do, though, which is interesting, is if we know that there was possibly a side effect with the receptor, we can take the receptor we think creates the side effect and see if it's binding effective. So we can do this to explain effects we've seen in drug testing. So this makes it more efficient to identify off-target or side effects of drugs. So what does this mean to you as the patient? Well, it means that drugs will be discovered faster and they'll be more efficient for you. It also means there'll be less side effects, so the drug won't be binding off-target as much, so we'll be able to predict that. And also, the most interesting thing, it's going to lead to a rise in personalized medicine. What this means is that instead of just getting a generic drug at a generic dose, you get a specified drug at a specified dose. Now we can use your genealogy for this, and we basically predict how can we get the best effect based on you as a person. So, this means thumbs up. How is this limited, though? If this wasn't limited, why weren't we using it all the time? Well, we have limited data sets, because biology is really complex, and there's a lot of drugs and receptors and all that stuff. Also, it faces slow adoption because of how limited it is right now. So, less companies are investing than a lot of experts hoped. This is leading to slow adoption. And also, training models and gathering data is expensive. This also brings up a second point, that medical data is actually really sensitive information that you have to really care for. Now this brings up data gathering. So there's two sides to data gathering. There's the good and the bad. So first, I'm going to talk about the good. First, we have to acknowledge a model needs a large data set to be effective. This means we need data. And while data breaches do happen, and these can expose sensitive information like medical records, these do happen less, as a spike in breaches has caused a spike in IT awareness. And if you want to talk about a successful use of data gathering, you got to talk about FinGen. This is a gene mapping program from the University of Helsinki that had 500,000 Finnish citizens as volunteers. Now, all members of the study were volunteers, and their data has led to just under 2,000 disease gene relationships being discovered. This means that if you get a gene test now, there's more that they can understand from you as a person. Now let's talk about the bad. A lot of large language models, like ChatGPT, Denali, they'll train off the web. Now what this means is that they'll train to produce copyrighted information, and it'll also produce offensive content. I personally had ChatGPT tell me that the moon landing was faked, and that JFK may not have been killed by the CIA. Many artists claim that models like Denali use their art. There's also a funny occurrence that models trained off of stock images will generate the stock image copyright thing. So if you do generate an image and it has a stock copyright, then you know what's happening. So what laws are governing AI? Well, if you want to have a laugh, look up monkey selfie copyright lawsuit. It's really funny. A judge had to rule on that. So AI creations are not copyrightable, as they're not human. So it's like a loophole for a lot of things. There's no laws against training a model on copyrighted stuff, because technically, you're not infringing on copyright. Your model is, and your model's not human, so it's not technically illegal. This is according to a professor at Albany Law School. And models may be liable for what they produce. Australian politician got libeled by ChatGPT, and now he's suing them. That'll be interesting to see what happens there. In conclusion, so I started by asking, what is AI? So I'm going to answer that now. Well, AI is math. It's just math, it's computing. So AI is a tool, because math is a tool, right? Now, is this good or bad? Or is it just math? That's not for me to decide. It's kind of a personal thing. That's the beauty of AI. AI is what you think it is. So how can you learn more? Well, of course, Google has something, right? They have everything. There's also Data Camp. It's more specialized. You can get a certificate, but pretty expensive. And there's also a new website, Make AI. So have you ever heard of Scratch? So Make AI, it's the collaborator for our slides. They want to make it easier to learn AI. Using block-based design, you can build your own AI on the web and train it on your own data. Currently, they have a demo where you draw a number and it will recognize it. And then this is just showing how you can get AI on the web. And the work in progress right now is a build it. Basically, you build your own AI, you train it on your own data. That's what the work in progress is right now. And you'll basically test it down here. You'll be able to predict, your model will predict what, off your data, what it thinks it is. Yeah, that's all I have. These are my sources. All right, thank you. Not sponsored.